Guys, what's up? I'm engineer AK, and today we are going to start another course by the name of engineering mechanics statics, or in generally we call it statics, right? And the book that is I'm following for this course is engineering mechanics statics by Meriam and Kraige, and it's the 7th edition and volume 1, right? And this is the cover page of the book, engineering mechanics statics, Meriam, Kraige, 7th edition, right? So let's get started. So the first chapter is introduction to static, right? And the first topic is mechanics. What is mechanics? Mechanics is the physical science which deal with the effect of force on object. So in mechanics, what we study the effect of force on object, right? Like if we can see that the force that a person is applying on this object has some effect. What effect it is producing? It is doing some motion, right? So it is mechanics. It come under the mechanics, right? Now after that, parts of mechanics. So the subject of mechanics is logically divided into two parts, right? There are two main parts of mechanics. The first one is static, right? And what does static mean? If we see this word, so static generally means something that is stationary, right? Or which concern with the body which are at rest. Balance forces are there. Mean if I say, like, let's suppose this is a door, right? Or anything, and if there is one person, right, and it is applying some force on this door, and there is another person, right, and he is applying the same force, and this door or anything is not moving. So again, we can say that it is at rest, right, or is in equilibrium, or we can say that there are balance forces. So if we see here, so these two persons, right, so this here they have hold a rope, and if they both apply equal forces, so still the rope will remain here, and if they are not applying any forces, so we can see that the rope is still at rest, right? So this is the static. And if we talk about the dynamics, so what is dynamic? It concerned with the study of forces and their effect on motion, right? That what are the forces and their effect on motion, right? Like the forces, how it is, what effect it has on its motion. Like this person is applying some force on the wall, and that is doing a motion. And if we see this one, so this person is applying some force on this object, and it is doing some motion, right? So we can say that in simple word, we can say that dynamic is something that is concerned with a motion, right? Now moving further, so in dynamic there are two types, all right? So the first is kinematics, and the second one is kinetics, right? So what is kinematic? Just discuss the motion, right? In this we discuss the motion, that what kind of motion, or in which direction is the motion, or we just say that we just discuss about the motion. And in kinematics kinetics, we study about the motion, right? We study about the motion, and with motion we also study about the forces that is causing that motion, right? So here we discuss two things. Here we just discuss the motion, right, in kinematics, and in kinetics we also discuss the forces that is causing this motion, right? So hope you understand this. Now moving further, so there are some basic concepts, right, that we have to understand it. So what is force? It is the action of one body on another body, right? Like if I show you, see that the person is applying like one body is applying a force on another body. Like this person is one body, if we consider is one body, and the cycle is another body. So this person is applying a force on this cycle, and it is doing some motion, right? So we can understand the force from here. Now second one is particle, right? What is particle? So we can say it is a body that has negligible dimension. Like for example, if I talk about this dot, right? So this is at center. So we can see that like still it is possible to study it, but if we see with our eye, so we cannot calculate its dimension, like its length, height, or all those stuff, right? Okay, so now another topic is what is rigid body. So a body that is considered rigid when there is when the change in the distance between any of two its point is negligible. Let's suppose if I take this object, right, and here I place one atom, right, and here is another, right, and if I apply multiple forces on it, like for example, if I am applying this force from here, from here, from here, like I am applying random forces on this, right, and still this distance will not change, right? So we can say we consider it as a rigid body. In nature, like in the real world, there is no rigid body, because if we apply a force on any object, so after some time or after exceeding point, we will see that atom that object will also show some deformation, and we can say that the distance between their particle will change, right? And if I show you a simple example, so we can see that there is a person, right, and we are like there is a statue, a kind of statue, and we can see that multiple forces are acting on it in different direction, but look at this. But now we can see that the still its dimensions are not changing, so we can call it a rigid body, right? Hope so you understand that. Now what is mass? Now you guys all know that what is mass. So in simple word, if I say, so it is the resistance to change in velocity, resistance to change of velocity, right? Or we can say that it is a mass can also be defined as the quantity of matter in a body, right? That how much, for example, if this is a mass, so how much matter is in it, how much matter is in this object, right? So we can also call it mass. Now what is time? It is a change, or we can also call it is an interval, or the interval over which a change occur, right? So it is an interval, right, in which something or change occur. What is space? It is the geometric region occupied by a body, right? If I, for example, if this is some plane or something, so so what is it? Geometric region occupied by, so here if this atom or object is occupying some space, right, or some region, so we call it a space, right? Now moving further, so now fundamental principles, and here are different laws of Newton. You have also studied in your FSC course or in your college course, but now let's revise it. So first law, so what the first law say? If the resultant force on a particle is zero or no external force, for example, if if object is moving something like that and there is no forces acting on it, for example, this is a ball, right, and it is moving in this direction and there is no other force and it is keep going in this straight line, so we can say that it is following Newton's first law. Or the particle will remain at rest, right, or continue to move in a straight line. As I told you, like if it is if this ball continue to move in straight line, or will be in equilibrium, right, if it is in an equilibrium state, right, or we can say that if it is at rest. And if I show you through a short video, like if we see this ball, right, so there is no force acting on it and it is moving in this direction, right, it is moving in this direction, and you can see that there is no change, so we can call it is following the Newton first law, right? Now moving toward Newton's second law. So what the Newton's second law says that the acceleration of a body is directly proportional to the applied force, or if we can say that you have seen this equation that A is directly proportional to F. A mean acceleration is directly proportional to F and inversely proportional to M, right? This is what Newton's second law say. So if we see through, let me show you, we see that the force is directly proportional to, or acceleration is directly proportional to force. It is applying this person is applying a force on this object, and it is having some acceleration due to force, right? And the greater the force, the greater will be the acceleration, and vice versa, right? Now moving toward the Newton's third law, the most famous law, you all may have heard this. For every action forces in nature, there is equal and opposite reaction, right? Here in this illustration, we can see that this ball and this ball, they are applying equal and opposite forces on each other, right? Now another important topic is Newton's law of gravitation, right? So what is it? That the two particles are attracted with equal and opposite forces. So let's see in this diagram. So it means that in universe, every force, each body apply some force on another body, but in opposite direction, right? So so that phenomena is compiled in this equation, right? So let's understand by in a simple way. Let's suppose I say that this is a person 1, right, and this is a second person B, right, and they are a friend, right? So this friend is represented by F. Their friendship is represented by F, right? And in friendship, we do friendship by likeness, right, or dislikeness. Or I simply write it dislikes, right? So what we what they friend are happy when they come closer to each other, right? When the A and B will come close to each other, so their friendship will increases, right? So F is directly proportional to the product of these masses. So if they come close to each other, so what will happen, that their friendship will increase, mean the force between them will increases. And what we don't like in our friendship, that we don't like to move further away from our friends. So if this friend B and friend A move further from each other, right, so what will happen, their friendship will get weakened, right? So we can see that the force here is inversely proportional to the distance, right? So if in friendship, if the friend, they don't like to move away from each other, because if they move away from each other, so their friendship will get weakened. So hope you understand that what is Newton's gravitation law, right? Now another topic is system of units, right? So generally we have two system of unit. The one is SI, or we can say that the international system of units, and the second one is US customary units, or in short we can say that USCS, right? So international system of units, it is commonly known as metric system, right? So we can also call it a metric system, and it is an international standard for measurement, right? If we want to do in measurements, so we must know that how much it is. Like for example, if I go to a shop and if I want to buy 1 kg of sugar, so I should have some unit in order to tell the person that how much I need it, right? Same like if I want to go to the petrol station, right? And I want to buy some petrol, so obviously there should be some values or unit that I mentioned there, so the person will understand that what for how much like how much I am asking for, right? And there are different unit, base units and drive units. You all know that, like kilogram, meter, second, ampere, Kelvin, mole, candela, and so on, right? Now what is US customer units? So system of measurement used in United States, right? So this is also the units, but these units are generally used in the United States and some other countries as well, and based on the English system of measurement, right? Here I have mentioned some of the quantities from book. This table is from book, right? So as SI, let's suppose if I take mass in kg, so in US customary I will put a slug instead of kg. And if I take in SI unit, if I take a meter, so in US customary I will take a foot. And similar for second, it is second. And for the force, here in metric system we use Newton, and in US customary we use pound, right? And so on. Now unit conversion factor. What is conversion factor? First, a conversion factor is a number used to change one set of unit to another by multiplying or dividing, right? Like here it is in centimeter, right? But if I multiply or divide here something with this 1 centimeter, so it will convert it to another units, right? Like here is centimeter, here it become millimeter. So it is what? It is simply the number, right, that used for what? Changing one set of units to another, right? Either we will multiply it or we will divide it, right? Something with that number, so its unit will get changed, right? So, and I have mentioned this, there are some conversion factor. You can search on Google, so you will find the conversion factor for different units, right? Or for different parameter. Like here I have put for length, how you can convert it, length, area, for volume, for weight, for liquid volume, right? And so on. Now another topic is what is prefixes, right? You may have heard this word as well. So prefixes are the word placed before quantities, right? So we place this before quantities, right, to modify their meaning, right? So its meaning will get changed. Like if I have let's suppose for pressure I have a unit Pascal, right? So if I want to convert it into kilo, so what I would do, that I will put a symbol before Pascal, right? Here it is written that you have to put it before, right? So here it now its meaning is changed. First it was just Pascal, now it is Pascal, or you can write it, multiply it 10 to the power 3. A prefix is a physics simply refer to the addition of letter or symbol to SI unit of physical quantity, right? Here I have written it in order to shorten its figure for better understanding. As I told you that instead of this we can also write here, like instead of this k, I can also write here multiply by 10 to raise power 3, right? So what this have done, that its form becomes shortened. Like instead of writing this long number, right, we can just write a 10 and we'll write some power of it, so it is the shortened form, right? And it will, if I go for another prefixes, so this number will keep on increasing. So in order to shorten this number we use prefixes, right? And prefixes are used for expressing unit of physical quantity that are either very big or very small, right? So we can express in a simple way, like if either the number is very big or it is sometime it happened that the number is very small, so we can also use their prefixes, right? So here we can see that is a chart that I have searched it, right? So for deca and here for hecto it become 10 to raise power 2, for kilo 10 to raise power 3, mega 6, giga 9, and so on. And similarly for smaller number, right? Like if you see this one, femto. So here we can see it is too small number, so it is difficult to write it. So instead of this we can simply write it 10 to raise power minus 15, right? So this means same. So this is for what actually these prefixes are used. Now moving further, so here is another interesting topic, coordinate system. So coordinate system is the method for identifying the location of a point. Let's suppose if I place a point here, right? So how I will know that where this point actually is, right? So what I will do, that I will just place or draw a coordinates, right? So now for example this is 1, this is 2, this is 3, right? And if here I write it's 1 and 2, so this is lying somewhere here, right? And I call it x-axis, and I call it y-axis. So we can see that on x-axis it is at 3, right? In general I am just telling you, and y-axis is 2, right? So the coordinate system identify the location of a point, right? So here we understand that how it tell us about the location of a point. So in coordinate system there are two types of coordinate system. One is Cartesian coordinate system, and another one is polar coordinate system. So wait a minute. Okay, so what is Cartesian coordinate system? The Cartesian or rectangular, we can also call it a rectangular coordinate system, right? Consists of horizontal axis, x-axis, and a vertical y-axis, right? So here this line horizontal, this is x-axis, and this one is y-axis, right? This is y-axis, right, the vertical one, and this is x-axis, the horizontal one. And the point where the axis cross is called the origin. Here if we see that this is x-axis and this is y-axis, so they are crossing each other at this point, right? This point. So I will simply call it origin, or I will just represent it with the symbol O. Any point can be described as a distance it from the origin along the x-axis and y-axis, and written as x and y. As I told you, as we have discussed before as well, like let's suppose if I want to find the location of this point, so what I will do, that I will find that how far this is from the x-axis and how far it is from the y-axis. So it will, let's suppose it is in x-axis it is at 5, at y-axis it is at 5, and at x-axis let's suppose if I say it is at 4, so I will write it 4 comma 5, right? So it is the location of this point, right? And this is how the Cartesian coordinate system looks like. Now the another coordinate system is the polar coordinate system, right? So what is polar coordinate system? In polar coordinate system, r is the distance from the origin, right? Having a Cartesian coordinate, and let me move it. Okay, so here, so a polar coordinate system, r is the distance from the origin, right? So we can see that in this is the point, and the distance from origin till here it is r, right? And to having a Cartesian coordinates xy, and theta is the angle between a line drawn from the origin to a point and a fixed axis. So there will be this line will be at certain angle, right? Phi or theta or any other symbol you can write it. And here the fixed axis mean the positive axis, right? And the theta is the measure counterclockwise, right? We measure it counterclockwise, take as a positive, and clockwise we take it as a negative, right? So this is the two types of coordinate system, right? Cartesian coordinate system and the polar coordinate system. Now moving further, so another topic, scalar and vector. So the scalar is defined by its magnitude, and obviously there will be some units, right? For example, if I say that from here till here, right? So okay, I will say that its magnitude is 4, right? Let's suppose. But how much? 4 meter, 4 millimeter, 4 centimeter, 4 kilometer, right? So if I write here km, so it is clear that it is 4 kilometer, right? So we need two things for defining the scalar, magnitude and units. And for vector we again need magnitude and unit, plus we need another thing, direction. And if we see here, so this is scalar, right? And if I see for vector, so we need a magnitude and also a direction, right? At what angle this is, right? Now moving further, now let's discuss the type of the vectors. So the first type is free vector. So as from name it is sure that it is free. Action in space is not associated with unique line. Like if we see, so this line is moving here and this vector is moving in this direction, this vector is moving in this direction, mean they all are free, right? They are not on unique line. For example, if I see this is a line and if I draw here, so if we see that these are all these vectors, if I draw, so these all vectors are at unique line, right? In free vector they are not in unique line, right? Now the second type is the sliding vector. So action in a space is described by a unique line, right? So it will, now we can see that it is moving at a unique line, right? This vector is moving at a unique line. Here we can see that this is not moving from here, just like a free vector not moving from here, right? It is just simply following this green line and moving across it, right? So this is sliding vector. It slide on a unique line, right? It will not move away from this line. Now moving further, so the another type is the fixed vector. So action in space is described by unique point, right? So here we can see that this vector or this force or anything, it is applying a force on this unique point. For example, if it is a rigid body here, right? If I have a rigid body here and I apply a force just here, right? So it has a unique point, right? So we can say that it is a fixed vector. Similarly, we can see here it is applying just force here, or we can see that it is passing through just single point or applying a force on this single point. Similar here, right? So we can call it a fixed vector. Now another conceptual topic, the orientation of vector. So first of all is collinear, same or parallel line of action. We can see that these two vectors are parallel, right? Like in collinear we can see that or we can say that if it is a line, and let's suppose here is vector 1 and here is another vector, so it is also collinear. What it means, that it will having a line, right? Same line or a parallel. So here it is a parallel and here we can see that it is the same line, and here these vectors are parallel and in same direction. These are also collinear but in opposite direction, right? So collinear mean that it will be having a parallel line of action or same line of action, right? And direction doesn't matter, but the important thing is here that the line of action should be parallel or same, right? Moving down, so another is coplanar orientation. So it is located in the same plane, right? So we have same, or we can say that the parallel plane. Let's suppose if I draw a coordinate here, it is, I take it as x and I take it as a y, right? And here I draw a vector, right, at certain angle, and I don't know what it is, right? And here I draw another vector at certain angle, right? So like if here it is making some angle, so we can see that these two vectors are coplanar. How they are coplanar? Because they both are in xy plane. Like here it is a plane, right? We can see that it is a plane. So if they are in xy plane, right, so we can call it a coplanar. Now moving further, the another orientation concurrent, so passing through a common point. For example, if I say that there are this is a one vector, right, this is another vector, this is another vector, and this is another vector. So we can say that these all vectors are concurrent because they all are passing through this common point, right? Here we can see that these all are passing through this point O. So we can call that these forces are or these vectors are concurrent, right? Now moving further, so vector addition, right? So how we will add vectors? So there are two laws for the addition of vector. One is parallelogram law and the another one is a triangular law, right? So let's discuss these both. So parallelogram law, so what is say that when two vectors are joined tail to tail, right? Let's suppose here we can see that there are two vectors, this one, right, and this one, and they are joined by tail to tail, right? Their tails, we see that the tails of these both vectors are joined here. Complete the parallelogram. The resultant is found by drawing the diagonal, right? And if I draw, like for example, what I will do that from this vector I will draw a line here, right, and from this vector I will draw a straight line here, and then I will draw a diagonal, right? It is that diagonal that is passing through the center and moving to the opposite corner. So this we can say that it will be the resultant, right? And that's what the parallelogram law say, or in other word, if I say that we can easily make it, if I move this, like if I draw a line parallel to this over here, you can see it, right? And if I draw a line parallel to this vector, this one, and then I join their diagonal, so it will give me the resultant, right? This will be the resultant then, right? So this is the simple parallelogram law. Now a triangle law. So what this law say that when two vectors are joined head to tail, right? Here we will do head to tail rule. Now you know that what is head to tail rule, that the head of the first vector, right, will coincide with the tail of the another vector, right? And if we want to draw the resultant, so what we do that we will make a close triangle by drawing a resultant from the resultant vector, and its tail will be joined with the tail of the first vector, and the head of the resultant vector will join with the head of the last vector, right? So it is a triangle law. So let's see that when two vectors are joined head to tail, draw the resultant vector by completing the triangle, right? Here we can see that here first vector head is joined with the tail of the second vector, and if and we can see that the resultant head is joined with the head of the last vector, and its tail is joined with the tail of the first vector, right? So it is a triangle law. So through these two law we can easily add the vectors, and this is how we add or subtract vector, right? Here we can see that there is vector v1 and vector v2. Then we have just we can say arrange them in proper way, right? And then we have drawn a diagonal, right? So it gives us a resultant, or we can say that simply we join them and then complete this triangle, right? So it's a triangle. This is triangle and the B is parallelogram, and this is how we add these vector, right? Here we add up these two, and if they have opposite direction, we can see that if this is the positive, right, positive direction, and this is the negative direction, so we can also add it like we will close this because it is a minus v2, right? And here I will put a plus sign, so we add or subtract the vector by adding them, right? And the negative sign, then plus minus become minus, so that's why they directly write here negative. And if the triangles that are not right angle, right, here we can see that are not right angle mean there is no 90-degree angle, right? The following two laws are important then. One is cosine law, right, or law of cosine, and another one is law of sine. And you all have know this law, right? A square equal to b square. These are the sides, and the capital A, capital B, and capital C are the angles, right? And similar here, these are the angles and these are the sides, small a, small b, small c, and so on, right? We will do numericals on it in the upcoming chapter, so you will completely understand that how these laws are used. Now the last topic of today's lecture, the vector component, right? So the axis which the angle is made will be taken as cosine, and in front of it we will take sine, right? For example, if I always remember, if the angle is made with this axis, right, we can see that it is touching with the x-axis, right? So this will be taken as the cos component, right? Cos component, and this will be then the sine component, right? Like it has a simple trick. For example, if I draw here a line, and if I draw this vector, right, and it is making some angle with the y-axis, so then we will take this one as a cos. Sorry, my writing is not that good, and this will be sine, right? And if I take one another, let's suppose and I draw a line here, a vector, let's suppose I draw a simple vector over here, and it is making angle with this axis, so then this will be cos, and this will be sine. This will be sine and this will be cos, right? So this is the theory portion of chapter 1, introduction to statics. Hopes you all have understand all these concepts, right? And if still you have any queries, so let me know in comment section. And now in upcoming videos we will solve the exercise problem. So see you next video, and thanks for watching.